Good morning, ladies and gentlemen. Today we are learning about convection currents and tectonic plates. First, you will answer the question, what do you think causes plates to move? Remember, when I ask you what you think, I'm looking for what you know right now. There is no right or wrong answer except not answering. So go ahead and when you see this, create a text box on the right and answer the questions. What do you think causes the plates to move? Our essential question for the lesson is, what are convection currents and how do they relate to plate motion? A couple of examples of convection currents that you might see in your own home are when you heat a pot on the stove. The heat from the stove causes the liquid to become less dense and expand, and it rises to the top. Then when it cools, it sinks back down to the bottom to be reheated, and the whole process starts over again. The same process happens in your home. When you're heating it, the hot air rises, and as it cools, it sinks back down to the floor to be heated again, and the process starts all over. Watch this video about what happens when liquid is added to a hot, and watch some currents travel. Remember, there is no artificial heating being done here. The movement you see is entirely by some currents. You can watch the video as many times as you need in order to draw your model. On this draw it slide, you will be drawing a cross-sectional view of the convection currents happening in the cup. Remember, in a scientific model, you label everything, not only what you can see, but also the unseen forces that are taking place. Examine these models of convection currents and see what happens. Now, as we heat water in the pot, the convection currents will cause the wood blocks to move apart as the currents are flowing. The same process happens on the earth. The convection currents in the mantle cause the plates to move. You can watch this video about why it gets hotter as we go deeper into the earth. Make sure you answer the questions at the end. The plate tectonics that make up the Earth's crust are not stationary lumps of rock. They are continually moving at about 2 to 3 centimeters per year. Position of the plates that they are. Here's the position of the plates as they are today. The plates float on the magma beneath them in the mantle. At the surface, the plates are dragging in different directions depending upon the direction the convection currents are flowing in. So it's the convection currents that drive the plate motion. Here's another video, an animation, that shows that convection current process in motion. So you can watch that video as many times as you need until you completely understand the process. This process of heating, rising, cooling, and sinking forms convection currents within the mantle. It's called convection currents. The convection currents, the first step is the heat from the core causes the mantle to be heated at its base. The hot rock rises gradually toward the crust, moving further away from its heat source at the core and starts to cool down. When it reaches the crust, it is forced out sideways because it cannot easily pass through the solid rock above it. As it cools, it begins to sink back down towards the core. As it reaches the solid outer core, it is again forced sideways because it cannot pass through the solid iron-nickel layer, and at the same time it's heated up once again and rises to the surface. What was common between all these examples? That in every case, warm matter rises and cool matter sinks. In this activity, you will fill in the blanks. You will use the provided vocabulary words to fill in the blanks about convection currents. And finally, it is your time to climb. This is where you will be answering questions to review what you learned in the unit. Make sure you complete the activity. And that's our unit lesson on convection currents. Please feel free to watch it as many times as you need to. Please make sure you complete all of the activities in the unit. And if you have questions, we will review them and answer them when you come back to class. Have a nice day. See you then.